Ask My Instructor 4.8.43. F prime equals 3x plus sine of pi x. F of 2 equals 3. What is f? Well, we've got two requirements. Both requirements need to be satisfied. I'll first deal with the first requirement. F prime equals 3x plus sine of pi x. And what I'm going to do is I'm going to look for the antiderivative of 3x plus sine of pi x. To find that antiderivative, I first focus on the 3x. What is the antiderivative of 3x? To solve that, I use the power rule. The antiderivative of x to the p is x to the p plus 1 all over the new exponent. In this case, we have an exponent of 1. So x will be to the new exponent of 1 plus 1, or 2. And then, of course, I have to have it all over that new exponent of 2. Now let's focus on the antiderivative of sine of pi x. If you can memorize that the antiderivative of sine is equal to negative cosine, the antiderivative of sine is negative cosine. If you can memorize that, you're halfway there. Now let's add in the coefficient. The antiderivative of sine of ax is equal to negative 1 over a cosine of ax. Now why is that 1 over a, why does that show up? Well, keep in mind that if I take the derivative of the right-hand side, I have to come back to sine of pi of ax. I keep saying I want to say pi because remember the original problem had a pi. Well, let's get back to that pi. All right, we've got sine of pi x. I want the antiderivative of sine of pi x. Well, antiderivative sine is negative cosine, so I put in my negative. And then for the pi, I have to go 1 over pi. So negative 1 over pi cosine of pi x. And again, why is that the antiderivative? Well, take the derivative. The derivative of cosine is negative sine, so those two negatives will cancel. And then I'll have to use the chain rule. The derivative of pi x is pi, and that'll cancel with the 1 over pi. So what we're doing really when we do antiderivatives is we're working backwards. And so that's how I found that. All right, so we found the antiderivative of 3x plus sine of pi x. And remember, when we find the antiderivative, it's not really one solution, it's an infinite number of solutions. And they will all look like these graphs here. And these graphs are just vertical shifts of one of the solutions. So which of these infinite number of solutions is the right solution? Well, this is where the second requirement comes in handy. I look for the point 2, 3. If x equals 2, then f has to be 3. So where's the point 2, 3? Well, I find that, and that shows me which of these curves is the right curve. Now let's find the actual function f of x. So what we're going to do is we're going to be solving for c. We need to figure out what c is. To do that, I use the fact that if x equals 2, that the function equals 3. So every time I see an x, I put in a 2. So I have 3 halves. Instead of x squared, I put in 2 squared. And then minus 1 over pi. Cosine, instead of pi x, I have pi times 2. And then I have to have the plus c. The c is what I'm looking for. And all of that is equal to 3. What is c? Well, cosine of 2 pi equals 1. And then 3 halves times 2 squared is 6. Solve for c, and I get c equals 1 over pi minus 3. Great. So the c that I found, I put that back up into the f at the very top of the slide. Once I do that, I get f of x equals 3 halves x squared minus 1 over pi cosine pi x plus 1 over pi minus 3. Wow. Now that function satisfies 2 requirements. Its derivative is 3x plus sine of pi x. Check that that's true. The other requirement that it satisfies is that f of 2 equals 3. And again, you may want to actually check that that's true to convince yourself that that is the solution. And so you can see in the bottom right corner the graph, and the point f of 2 equals 3 is also graphed as well. So try your hand at this and let me know if you have any questions. Take care.